Hi, I'm Mr. Meyer. This video will be on the metric system and metric conversions. Just a quick piece with the metric system or SI system. Things we're going to be using quite a bit are length, and the length would be meters. How big is a meter? Probably the height of a preschooler, a little bit over 3 feet, or 2 meters would be typical social distancing of 6 feet. Let's see, mass in grams. Gram is a really small amount. There are 454 grams in a pound. A pinch of salt would be a gram. Time, temperature, amount of a substance, we'll deal with those later. We're going to be looking at volume quite a bit in this first unit. A liter is about the size of a quart. It's a little bit bigger than a quart. Density, it's grams per milliliter is what we'll commonly use, but it's any mass over volume measure. The density of water is 1.00 grams per milliliter. Here are some English to metric conversions, which you might have seen with dimensional analysis. That will not be the focus of what we're doing. We're focusing on metric to metric conversions today. Okay, I'm going to flip the sheet here. Let's see how this goes. I think we're doing okay. I have a chart here, and on this chart, we can take a look and see all these symbols and prefixes and things. And what happens is let's say I have a meter. There's no prefix in front of meters. Remember, that's about the height of a preschooler. And let's say I break that meter up into 10 parts. I'm going to have a decimeter, or 1/10 of a meter, and there's 10 decimeters in a meter. Break it up into 100 parts, it would be centimeter. Break it up into 1,000 parts, there's 1,000 millimeters in a meter. Break that millimeter up to 1,000 parts, or you have 1/1,000,000th of a meter, that's a micrometer. A nanometer is 1/1,000,000,000th of a meter, and so on down the line. In the chemistry world we're looking at, the atoms are probably 1 times 10 to the negative 10th or 1 times 10 to the negative 11th meters. So we're talking about this really, really small realm. Let's go back up the other way. If I have 10 meters, I have a decameter. 100 meters would be a hectometer. 1,000 meters would be a kilometer. If I had 1,000,000 meters, I'd have a megameter, and so on up through that way. Okay, let's go to some conversion problems. And we're going to show this using a couple of methods. One would be the dimensional analysis, which we have learned. So, dimensional analysis, I'm going to look at this problem. How many meters are in a 10-kilometer run? So using dimensional analysis, I'm going to write down what I know, my 10 kilometers. That's my starting point. I want to find out how many meters, so I'll put question mark meters. That's my ending point. Is there a conversion factor that links kilometers and meters? Yes, there are 1,000 meters in a kilometer, so I have a conversion factor. When you do this, you look at what you know. What you know goes on the bottom, the kilometers. What you don't know goes on the top, which is the meters. And then I plug in my conversion factor, and it becomes 10 times 1,000, which would be 10,000 meters. Does this answer make sense? I'm going from a bigger unit of measure to a smaller unit of measure, so I should have more of them, and I certainly have more when I have 10,000 meters. Notice 1,000 meters is the same as 1 kilometer, so I'm essentially multiplying my equality. I get the same thing, but it's just in a different form. But the distance is equivalent. Let's take a look here. How many kilometers are in a 400-meter run? I start with 400 meters. That's my starting point. My ending point is question marks kilometers. So I'm coming from meters, so this time the meters goes on the bottom. I'm going to kilometers, so the kilometers goes on top. And this time the 1,000 goes on the bottom because there's 1,000 meters in a kilometer. And I end up dividing by 1,000, I get 0.4 kilometers. Because I'm going from a smaller unit to a bigger unit of measure, I'm going to have less of them, so I get 0.4 kilometers right there. Okay, another way to do this is sliding decimals. So let's show that method for these two problems as well. So let's see, I think we're good here. How many meters are in a 10-kilometer run? So what you can do is write your 10.0 right there. And then I look, meters is the base unit, 10 to the 0 right here, and kilometers is 10 to the 3rd. Okay, I am going from kilometers to meters, so I am going down the chart. If I go down the chart, the units get smaller, but the numbers get larger because I have more of them, and I'm going to slide the decimal to the right. So I'm going to slide it 1, 2, 3 spots and fill it in with zeros, and I get 10,000 meters. Let's go back the other way. We'll look at our 400 meter run. I'm going to put 400 point right there. Meters is at 10 to the 0. Kilometers is at 10 to the 3rd, what we're trying to get to. I'm moving 3 places, but this time I'm going up the chart, so my numbers are going to get smaller, and I'm going to slide the decimal to the left. 1, 2, 3 spots, which gives me 0.4 kilometers. Let's do one more problem with that right here, and this would be a running race is 5 kilometers, find the centimeters, find the inches. Let's do dimensional analysis. I know my kilometers, I'm trying to find inches. Okay, well, I don't know that conversion directly, but I can go from kilometers to meters, meters to centimeters, centimeters to inches in order to get there. Notice if kilometers are on top here, it goes on the bottom here as I convert to meters. Meters on top here, meters goes on the bottom here as I convert to centimeters. Centimeters on top here, centimeters on bottom here as I go to inches. And if I round it, I get 200,000 inches, or 2 times 10 to the 5th inches. Doing the decimal slide, I can take 5 right here, and let's see, I'm going from centimeters, or I'm sorry, kilometers up here down to centimeters down here. So I'm moving 1, 2, 3, 4, 5 places. I'm going down, so if I'm going down the chart, the numbers get larger, so I'm going to slide to the right. So I'll put my 5 here and 5. 1, 2, 3, 4, 5. Fill those in with the 5 zeros. That gives me my answer in centimeters. I have to still do dimensional analysis to do an English metric conversion, so I do that to finish up the problem to get to inches. When I did the metric part by just sliding. Okay, finally, let's look at this last page right here. And I have a couple problems, and one of them is I'm going to go from a G, and then I got an mg right here. I don't see G here. Oh yeah, G must be for grams, and there's no prefix in front, so it must be my base units. It's a big mg, so it's not the milli, it's the mega. So I am going from 0 to, not 1, 2, 3, 4, but 0 to 1, 2, 3, and notice I skipped 3, so it's actually a movement from 0 to 6, which would be 6 places. All right, I'm going up the chart. Going up the chart, the numbers get smaller. Slide to the left. 6 hops this time. 1, 2, 3, 4, 5, 6. And I get 0.86 megagrams. Let's look at this. 30,000 milligrams, or I'm sorry, yeah, 30,000 milligrams right here at 10 to the negative 3rd, going to kilograms at 10 to the 3rd. Negative 3rd to 3rd is 6 decimal places. I'm going up the chart, so my numbers are going to get smaller. Slide to the left. 6 hops this time. 1, 2, 3, 4, 5, 6. Check it out now, y'all. 0.03 kilograms. The last one is 0.235 grams going to nanograms. I'm going from 10 to the 0 to 10 to the negative 9th. So what I'm going to do is put my 0.235 right here. I'm going down the chart. Going down the chart, my numbers get larger, so I'm going to slide to the right. 9 hops this time. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would mean 1, 2, 3, 4, 5, 6 zeros put in. I get 235 million, or 2.35 times 10 to the 8th. Freeze! Everybody clap your hands. Okay, enough of that. Try these metric conversion problems in your homework packet. Check your homework keys to make sure you are accurate. Condensed notes for this video are posted, and ask questions as needed. Good luck.